do factoring factoring special polynomials. Yeah, well, there's just other examples. There's kind of like just certain situations where we can factor them a little bit different. Now, so the first one I've kind of already broken to you because last time we were decomposing it. You factor by grouping and then we pull it out. But I was telling you guys that when the value up front was equal to 1, then it's a lot easier. We can actually do it like quite a bit quicker. So let's say in this example, right? So when a is 1, it just means when the number out front is 1. Then we can just throw down our brackets. And they both get an x. And then do you remember what our two numbers need to do? They need to multiply to... add to 2, yeah. So what I do in this case is I just say, okay, just forgetting about the negatives and positives for a second. What are some numbers that multiply to 8? 2 and 4, 1 and 8. But if I use 1 and 8, there's no way I'm getting from 1 and 8 to 2, right? But 2 and 4 would be good, so let's go 2 and 4. Doesn't matter if I would have put 4 and 2, right? Because the factors are the factors, doesn't matter what order they're in. Now I just got to figure out like the negative and the positive. So they need to multiply to negative 8. So the only way that you can multiply to a negative is 1 is negative and 1's positive. So, okay, 1's negative, 1's positive, I know that. Which one of these would be positive? The 4 would have to be, right? Because then that'd be plus 4 and minus 2. And now negative 2 times 4 is negative 8. And 4 minus 2 is positive 2. Okay, so those ones are quick and easy. And that's, to tell you the truth, that's the most common way that we're going to factor. Typically, there's going to be, it'll be a 1 out front. And if you guys end up taking like 20-2 next year instead of 20-1, this is the only one that you would have to do. You wouldn't have to actually keep on factoring if there was like a 2 out front of that or something. Or, I guess, a 3. 2 we could have done. Yeah, okay, so let's do this one. Actually, you know what? I'm going to pause it. Let's let you guys do these two. So I'm going to let you guys try to factor these two. Okay, so the numbers... Well, first off, let's throw down our brackets. And then would it be x and an x? A, right? Remember, so we were dealing with a's this time. So a and an a. And then the numbers that I'm looking for need to multiply to 18 and add to 7. So I'd be thinking, okay, numbers that multiply to 18. So yeah, it's 9 and 2. What? And if I said 6 and 3, let's say, what if I was like 6 and 3? Okay, that would work for multiplying. Is there any way I'm getting from 6 and 3 to 7? Like if I add 3 or subtract 3, I'm not getting there, right? But 9 and 2 is a good candidate. So 9 and 2. And then, okay, so they need to multiply to negative 18. So one's got to be negative, one's got to be positive. Which one's got to be positive? Yeah, the 9, right? Because that'd be positive 9 minus 2. So 9 minus 2 would give you positive 7. So we're good to go there. Yep.
Would it matter if you had like a minus 2 bracket 8 plus 9?
It would not matter, no.
Yeah.
And it would not matter because it's the same type of thing if you had 3 times 4. That's the same thing as 4 times 3. Right. So when you're multiplying factors, like the order doesn't matter. So, okay, so this one, all right. Well, you know, typically what I would do on this one right at the bat, do you guys remember with polynomials, you can kind of just move these terms around however you like? Let's do that first. Let's put the m squared out front, then the m, and then the number on the end. So that'd be m squared plus 7m minus 30. Okay, and then I'm going to throw my brackets down. And they both get an m. And I'm looking for numbers that multiply to 30 and add to 7. 10 and 3. Okay, let's try that one. So 10 and 3. So they need to multiply to negative 30. So again, one's got to be negative, one's got to be positive. Right, so the 3 will be negative, the 10 would be positive there. Good. All right. The next special type of factoring is something called a difference of squares. Okay, difference of squares. So first off, I'm going to we just kind of work backwards here. If we started off with x minus 5 and x plus 5, I just want to show you guys a little pattern and why this is going to work. So if I kind of start backwards, I'll start at the end and kind of work my way the other way around. So let's FOIL this, or let's like, rainbow it in. So it'd be x times x, x times 5, negative 5 times x, and then negative 5 times 5, right? Just multiplying that in. X times x would be x squared. X times 5, doing like that one, was 5x, so plus 5x. Negative 5 times x is negative 5x. And then negative 5 times negative 5 is negative 25. So now we would collect like terms, but look what happens here. 5x minus 5x, what's that?
0.
0, right? They just cancel each other out. Those middle terms are gone. This ends up just being x squared minus 25. Okay, so this is why this one works, is because those middle terms cancel in this situation. Where if we get a situation where we have, like this one, x squared minus 25, where this one's a perfect square and this one's a perfect square, right? Like x squared is a perfect square, right? Because it's x times x is x squared, and 25 is 5 times 5. So two perfect squares, and we're taking the difference, right? Subtracting. So difference of squares. Then we can factor these ones really easy. You can just throw your brackets down. And then it's the square root of the first one goes into both of them. So it's an x and an x in this case. Square root of the second, so 5 and a 5. And then one's a minus and one's a plus. And that's it. And we can do this with any difference of squares. So let's try another one. Let's say that we had, x to the 6 minus 36y squared. And I know there's more going on there, but really we've still got perfect square, and these are both perfect squares as well. And we're taking the difference of them. So it's this easy where we can just throw our brackets down. And so the square root of x to the 6, what would that be? X to the 3, right? It's like half of the exponent there. So it's going to be x to the 3. So they both get an x to the 3. And then square root of 36 is 6. So they both get a 6. And then we also have to do the y. The square root of y squared is y. So they both get a y. One's a minus, one's a plus. Does that make sense, guys? Okay, those are actually pretty easy. The hardest part about the difference of squares ones is actually just recognizing it when it's there, right? Like when you saw this and it said factor this, it's really easy to do, but you might not recognize that they're all perfect squares in that situation. So let's do a couple more. I'll let you guys do these ones actually. So can you guys go ahead and factor all 3 of these? So guys, let's do the first one here. A lot of you guys got this one. As soon as I recognize that it's perfect square, and I'm taking the difference of them, then we can just throw our brackets down. They both get an x. And square root of 9 is 3, so they both get a 3. One's a minus, one's a plus. Okay? Next one, throw your brackets down. Square root of 16 is 4, so they both get a 4. Square root of a squared is a. They both get one. Square root of 25 is 5, so they both get one of those. Square root of c squared is c. One's a minus, one's a plus. Done. All right. Now, this one's not as bad as you think. You guys did questions kind of like this in the first lesson, right? Where, do you guys see how we've got, well, 7 and 28, they have things in common. And g and g to the 5, those have things in common. So you always want to factor out what you can first, because there might be something kind of hidden when we're done here. So what goes into 7 and 28? 7. 7 does, right?
I think we have like 4 different answers there.
Yeah, and 7 is a prime number, so that, yeah. Okay, but anyway. Okay, so what about g cubed and g to the 5? What goes into both of those? G to the 3, or g cubed, yeah, it'd be the smaller power there, right? So g to the 3 is common. And then the h's aren't common to both, so I can't take that out. So now we'll start a bracket and write what we have left. So what do we have left here? H squared minus 28 divided by the 7 we took out is 4. And then g to the 2. Hey, perfect. Perfect square, perfect square, perfect square. So then we're just going to leave this 7g cubed out front. It just kind of hangs out. And then for this part, we're going to rewrite it. I'm just going to throw my brackets down. Square root of h squared is just h. So they both get an h. Square root of 4 is 2, so they both get a 2. And then square root of g squared is g. One's a minus, one's a plus. So that's fully factored. How many factors are there? 3, right? 1, 2, 3 factors. There's like 3 things multiplied by each other. Okay. Let's say, why is it not possible to factor this one? Well, it's really because, yeah, it's a plus sign there. It's not like a minus. This isn't a difference of squares. So, yeah, right? You might at first have the tendency to be like, okay, m and 4, m and 4, and you were adding them? Yeah, so if we distributed this, right, you'd have m squared, you'd have m times 4 is 4m, and then you'd have 4 times m again is 4m, and then you'd have 4 times 4 is 16. And do you guys see how the next step here, I'm going to add those. So this would be m squared plus 8m plus 16. So that's the difference here, is that it's not a difference. Sorry, that was confusing but funny, right? Okay. Is that these end up like adding together? They don't cancel out like the last one, right? So the only way they would cancel out is if this is a difference of squares, right? So you can't add them. So be careful for that, because that's kind of a common like trying to throw you off question, where they'll say factor this, and you need to know that you can't factor that. It's not factorable. Okay. Perfect square trinomials. Perfect square trinomials follow this pattern, where you can write it out. So if you've got, like in this situation, if this is my like A, and that's my B, and that's my C, it's going to follow this pattern where, yeah, you know what? So guys, just factor it like normal. So let's even just factor this one. This way. So if we factor this one, you're going to see that you throw down your brackets, and you get an x and an x. And we're going to multiply the 9 and add the 6. So what two numbers do that? 3 and 3. And they both end up being the same. So this is what's called a perfect square trinomial, because they end up being the same. And you could rewrite that as x plus 3 squared, right? You could just write that out like that.
Can it just be 6x too?
No. Yeah, you guys can write this one down. So this is going to be a special case.
That's
not bad.
Wait, we have to do this?
All right, so on this one, what we're going to do here, can you guys see, well, does anyone have any ideas where we could start on this one? Yeah.
Do we expand each of the brackets separately and like factor the whole thing?
You actually kind of could do that. You could expand the whole thing out. Like that would take a long time, right? I could expand all of this out. I could expand all of this out, collect like terms, and then factor that. That actually might work out that way, but I got a different way.
Just your face down.
It was a good idea. The only problem is that sometimes, like, that'll take a lot of work too, right? Like, it's going to actually be quite long to do all that. The other thing we can do, can you guys see that this x minus 2 is the same as that x minus 2? Why don't we call that, just for a second, I'm just going to give that the value of a. X minus 2, I'm just going to call that a for a minute. I'm going to rewrite this as just a squared plus 3 times a minus 15. I'm just going to leave it like that for a minute, okay? And we're going to just remember that a really is x minus 2. Would you guys be okay with factoring this one?
Yeah.
Let's factor that one. We'll just throw down our brackets. They both get an a. And I'm looking for numbers that multiply to 15 and add to 3. Yeah, 5 and 3. So 5 and 3. And then one's got to be negative, one's got to be positive, right? 3 is negative, 5's positive. Okay, so perfect. We factored that. But remember what a was? Yeah, a was really x minus 2. Okay, so we're just going to throw that back in now. So instead of an a, I'm going to write that out now as x minus 2. Yep. Thanks, guys. Someone said 3. Oh, sorry, this should have been a 2 in my question.
Wow.
I made it up off the spot. Give me a break.
No.
You didn't give the jury a break.
All right.
You shut my.
yeah, right. So there, I just changed the original question. Sorry, guys. Okay, so now x minus 2, and then plus 5, and then that a was x minus 2, and then minus 3.
What about the square? Oh, never mind. I figured that out.
Yeah?
Could it be an a instead of an x?
No, so remember this a, right, was x minus 2. We're just kind of putting it back into x's now. Okay, so now I can just kind of simplify this out a little bit, right? Let's write this now as x, and then I can collect the negative 2 and the 5. Those are just like terms. So this is really just x plus 3. And then this one would be x minus 5. There you go, we factored it. We would have got the same thing if we did it did it the other way. You would have expanded it all, simplified it, and then you could have like factored it again to get that.
Good piece of same
Yeah.
prints off.